Chapter 1, Measurements. So what is a physical quantity? A physical quantity consists of a numerical magnitude and a unit. So the unit, the SI unit for length is meter, symbol M. For mass is kilogram, symbol kg. For time is second, symbol S. Electric current, ampere, capital A. For temperature, Kelvin, capital K. So next is the derived quantities and its corresponding SI units. For area, it's meter square. For volume, it's meter cube. For speed, it's meter per second. Because length is in meter, time is in seconds. So it will be meter per second. Next, let's look at prefixes and their symbols. For tera, the symbol is T, capital T, factor of 10 to the power of 12. Giga, 10 to the power of 9. Mega, 10 to the power of 6. Kilo, 10 to the power of 3. Deci, minus 1. Centi, minus 2. Milli, minus 3. Micro, minus 6. And finally, nano, minus 9. So these are the only prefixes that you need to memorize. Next, let's look at different physical quantities that you need to also memorize. The more important magnitudes to take note of is the diameter of an atom, which is 10 to the power of minus 10 meters. For diameter of the earth is 10 to the power of 7 meters. Okay, next, let's look at instruments to measure length. First, we have a measuring tape. So measuring tape, the precision to how accurate it can be measured is 0.1 cm. Meter rule is the same, 0.1 cm. Digital caliper is 0.01 cm. Micrometer screw gauge is 0.001 cm. Next, let's look at how to use a caliper. So it can be digital or it can be the vernier caliper. This is the inner jaws to measure inner diameters. These are the outside jaws to measure external diameters. There is a tail that can be used to measure the depth. For micrometer screw gauge, it's only this one where it's used to measure the length or diameter of objects. And it's more precise. As we have seen before, it's at 0.001 cm. Next, something to take note of is parallax error. So how to prevent this is by looking at the object directly. So this will avoid parallax error such that the line of sight is perpendicular to the markings on the meter ruler, okay, or the instrument that you're using. So how do we measure time? We actually use a stopwatch. So the period of a single pendulum is time taken for one complete oscillation, which means the ball will go from R to S and then back to R. Okay. And how do we reduce the error is by taking a 20 average time by taking 20 oscillations. Okay, so how does this prevent or reduce the error? The precision of a stopwatch is 0.1 seconds, and your human reaction time error is about 0.3 to 0.5 seconds. So by taking an average reading, okay, we actually increase the total time taken so that the percentage of error is smaller. Now, let's look at scalar and vector quantities. In scalar quantities, it only has magnitudes. In vector quantities, there is magnitude plus direction. Okay, so common scalar quantities are distance, SI unit meter, speed meter per second, mass kg, energy joules, time seconds. For displacement, it's actually the vector quantity because it comes with direction. So vector quantities and direction. So displacement is the same. velocity is meter per second, acceleration is meter per second, force is Newton, weight is also in Newton.